Hello everyone, my name is Chaoling from Nanjing Tech University. Today my topic is numerical study of PEMFC, heat and mass transfer characteristics based on roughness interface thermal resistance mode. So in the 21st century, the extensive consumption of fossil fuels such as coal, oil, and natural gas has produced a large amount of greenhouse gases such as CO2, which has led a dramatic deterioration of the global environment. The development of renewable energy sources instead of fossil fuels has gradually become a hot topic of concern for governments, enterprises, and researchers. Fuel cells are, in a broad sense, a real renewable energy source that can completely solve the energy crisis of human beings. Compared with other types of fuel cells, the PMFC has the advantages of high efficiency, low noise, fast startup, and long life, which is especially suitable for use as a mobile power source or distributed small-scale power source, and is considered to be the fuel cell with the best commercial prospect. Our research firstly compares all the thermal contact resistance between components into the three-dimensional two-phase non-isothermal mode of PMFC, and then study the effect of TCR on the heat and mass transfer characteristics of PMFC in 0.9 flow channel and different component surface roughness conditions. Its mode description. The PMFC consists of bioplant gas diffusion layer, catalyst layer, and photon exchange membrane. Figure 1 shows the separation flow channel structure of PMFC. In order to better demonstrate the separation flow channel structure, Figure 1 does not include the pipeline. Hydrogen and air flow in through the inlet of anode and cathode gas channel, respectively, and reach the Cl to participate in reaction under the diffusion effect. An unreacted gas and reaction water vapor flow out from the outlet of gas channel. The photons generated at the anode are transferred to the cathode source the PEM, and the electrons generated at the anode and transferred to the cathode source the pipeline and the external cushion. Figure 1b shows the great division of the computational demand of the PMFC mode with additional pipeline. So the third is mode variation. Before performance numerical calculation, the effect of great number on the calculation results is examined to obtain great independent solutions. Cl circuit density, responds to the performance of the PEMFC during operation, and is one of the most important parameters of the PEMFC. Figure 2 covers the current density obtained by solving difference greater as 0.6 V output cell voltage respectively, and the cell current density tend to be established with an increase of a great number among them. The cell current density tends to be stable when the number of grids is more than 25 million. Consider the computational efficiency and computational accuracy requirements. The first grid is chosen the final computational grid with the grid number of 73,076 to verify the accuracy of the mode. The simulation results were compared with the experimental data measured by Lucica at 353 Kelvin. Reticular follow channel across the section and 1 bar air pressure. The results show that the polarization curves of the mode in this paper agree with the experimental data with an error of no more than 5%. Including that the mode in this paper can accurately predict the operation of subprime follow channel of PEMFC at steady states, and the comparison results are shown in Figure 3. And the basic simulation parameters used in this study are shown in Table 3, and the material physical parameters are used shown in Table 4, and the subsequent calculation and analysis are based on those parameters, with a parameter is changed to analyze in this flight, and the other parameters are kept constant. The detail you can search our research paper. So next is comparison of PEMFC performance and the different conditions of TCR. So A is polarization curve comparison, and B is power density curve comparison. So Figure 4A shows the comparison of polarization curve of PEMFC for the 4 TCR operating condition. When the output cell voltage of PEMFC is higher than 0.6 voltage, there is almost no difference between the polarization curve of the 4 operating conditions. This is because when the output cell voltage is higher than 0.6 voltage, only a small amount of ionization and reduction engines participate in the reaction of the PEMFC. So the overall performance is low and the performance impact is more. The best performance of the ideal mode without TCR can be found when the output cell voltage is below 0.6. The cell current density gradually decreases with increase of TCR between commas, and the lower of the output cell voltage, the faster the cell current density decrease. Under the output cell voltage of 0.3 condition, when the surface roughness of PEMFC components equal 1, 2, and 3 UM, the performance of the cell decreases by 6.56 and 12.46 and 17.17% respectively. And figure 4 shows the cell power density curves of the PEMFC for 4 different TCR operating conditions. When the cell current density is lower than 1 MP per cm, the cell power density curves of 4 conditions remain consistent, and the cell power density of the no TCR operating condition is largest when the cell current density is higher than 1, and the cell power density of PEMFC gradually decreases with increase of TCR between components. And under the cell current density of 1.2 condition, the cell power density of the PEMFC decreases by 3.76, 8.47, and 15.46 when the surface roughness of PEMFC components equals 1, 2, and 3 UM. And the next part is temperature distribution. As we can see from the figure, the temperature distribution of Y is equal 0.01 meter across the section for the 4 TCR conditions at the PEMFC operating temperature of 353 Kelvin, and the output cell voltage of 0.6 voltage. The cathode cell is the main reaction generation room, and 80% to 90% of the cell heat production is generated in the cathode cell. So its temperature is the highest, and the finger also represents the no TCR condition. The temperature distribution of cross section is consistent with the simulation results of Chu Huamin and Bernie. The temperature of the cross section shows the trend of different in all directions centered on the cathode cell, and the temperature difference trend is strong in a range of cross section close to the gas inlet, and gradually decrease in the part of the cross section far from inlet. And the next is member order contents. And as we can see, the distribution of membrane stays water content on the membrane surface near the cathode for 4 TCR operation condition at cell operating temperature of 353 Kelvin, and the output cell voltage of 0.6 voltage. The circle box on the graph represents the region with the lowest film water content, and the regular box represents the region with highest film water content. And the finger also shows the condition without TCR. The distribution of membrane water is more uniform, and the water content inside the membrane is larger. The maximum value of membrane water content equal 15.15, and the minimum value is 7.89. So the finger is also shown with the increase of TCR. The water content inside the membrane gradually decrease. The maximum value of membrane water content are 15.03 and 14.93 and 14.94. So meanwhile, which is membrane current density closed plot of the four TCR conditions as a cell operating temperature of 353 Kelvin and output cell voltage of 0.6 voltage. It is found that with the increase of TCR, the current density on the membrane show a trend of becoming smaller, and the circle box on the finger represents the area with the smallest membrane current density, and the rectangular box represents the area with the largest membrane current density. So next is comparison of the effect of each TCR on the performance of PEMFC. Considering only the TCR between the A is polypline and GDL, and B is GDL and CL, and C is CL and PEM, and D is also repeat the condition. So we can say from this figure that it is known that the TCR between the polypline and GDL has a small effect on the performance of the PEMFC. The main reason is that the TCR between polypline and GDL only exists in the part of the polypline where the rims are in contact with GDL, and the gas photo channel formed by polypline and GDL is filled with photo oxides and reductor, so the heat transfer from the membrane electrical is mainly carried away by convective heat exchange with the oxidants and reductant, where the heat transfer between ribs and GDL is less. Therefore, the TCR between the electroplane and the GDL has less influence on the cell performance. Is comparison of influence of different TCR between CL and PM on the performance of PEMFC. The A is position cruise compression, B is power density cruise compression, and it also can be shown from the finger. And the compression cruise of PEMFC performance improvement by different numerical value of TCR between CL and PM, from which it is found that when the TCR between CL and PM is 0.003 and 0.005 and 0.01, the cell current density is improved 2.3%. And the condition of 1.2 ampere per centimeter cell current density. The cell power density is increased by 1.24%. And it also shows that it can be considered in the process of memory electrode fabrication to increase TCR between the CL and the PM by reviewing the fabricating process, especially the memory electrode assembly made by the researchers, not a professional production plan, but because the surface of this memory electrode assembly is more rough and easy to produce large TCR. So the memory electrode made by researchers can consider increase the thermal pressure and other condition to reduce TCR. The next is comparison of the effect of CL and PM TCR on performance at different temperature. Comparison of effect of CL and PM TCR on performance at A is 343 Kelvin operating temperature. B is 348, and C is 353 Kelvin temperature. So the last is conclusion. It is found that under the same operating condition, the TCR makes the radio heat transfer of PEMFC decrease, and the temperature of memory electrode and temperature difference of each combination of PEMFC is larger than that of the mode without TCR. When the surface roughness of compounds in the PEMFC equals 1, 2, or 3, the cell current density decreased by 6.56%, 12.46%, and 17.17% respectively. When without cell voltage equals 0.3 voltage, and cell power density decreased by 3.74 and 7.54 and 13.14% respectively when the cell current density equal 1.2 and per cm. So the results show that the effects of TCR cannot ignored, and to be some extent it can improve the efficiency of the system of PEMFC. So that's all my presentation. Thank you.